circles and arcs. I'm going to start by naming arcs. This circle would be circle G. That's the way we would name it, with its center and a little circle symbol in the front. Now when I name minor arcs are less than half the circle. So they're named with 2 points. Okay, so I started here at R and said RS, then went around ST, TU, UQ, all those arcs, QR, and then I'm back at RS again. So then I did those, the simple ones that we can see, and then I did some that double up, like QS. QS has, 2 adjacent arcs in it, but that's QS. It's still less than half the circle. Then I had QT, or TQ, you can name them either direction going this way. It has 2 adjacent minor arcs in it, but it's still a minor arc. And then UR. UR has 2 adjacent arcs in it, but it's still a minor arc as well. And then for the major arcs, for every minor arc, there's a major arc. The minor arc's less than half the circle, so the major arc's more than half, so it's going to be the rest of the circle. So if I had arc RS up here as a minor arc, then I could say arc RUS going the other way around the circle. See, this was arc RS here, and the rest of the circle is going back the other way. That was a major arc. And you have to name major arcs with 3 points, showing that you're going the other direction. From R to S, now I'm going from RUS. And any one of these points on that major arc you could put in the middle, but it's still that same major arc. And then same thing with ST. I had ST, so I went the other way, SUT. And for TU, I'll go the other direction, TSU. For UQ, I went the other direction, USQ, and so on. I did that with each of the arcs. Each minor arc, I just went around the circle the other direction. So I have the same number, 1, 2, 3, 4, 5, 6, 7, 8 minor arcs. I should have 1, 2, 3, 4, 5, 6, 7, 8 major arcs. Then semicircles. Semicircles are half the circle. Whenever you see a diameter, you get 2 semicircles. And you have to name semicircles with 3 points as well. See, because we know that ST is the points that are going to be on either end, STU and SRU, going the other direction, or SQU if you wanted to name it that way. But go from one end point to the diameter to the other end point of the diameter around the circle, and then the same on the other. That's why you have to name 3 points. You wouldn't know which side you're talking about if you didn't have 3 points. All right, and then for the other diameter, RT, I went RST, and then I went RQT, the other direction. So those are the semicircles. Now this next one is why it's so important that you draw your circle and put your measures in. It makes it a whole lot easier to find the measure of these arcs. See, they didn't give us a whole lot in this circle. This is circle B. They told us that's 90 degrees, so we know that its arc's 90. If that's 90, that angle on this side, GBH, would have to be 90, so that arc would be 90. And of course, JH is a semicircle, so that makes sense. 90 and 90, that'd be 180. And since that's the diameter, making this a semicircle, and those are 90 and 90, then these two would have to add up to be 180 also, because it's a diameter. So 151, that arc's 151. And then, of course, that arc would be 29, and the little angle here would be 29. I can squeeze that in there. They're not asking us angle measures, they're asking us arc measures. We've got the 4 major arcs, or 4, not major arcs, but the 4 arcs that we can just kind of look at on here and see, 90, 90, 29, and 151. But what we're going to be using is arc addition here on some of these, because we have to add adjacent arcs to get larger arcs. They started off with GJ. GJ was 90. HI was 29. We got that. HIJ. So HIJ is a semicircle. So that's 180. GJI. GJI. See, we're adding from this 90 and this 51 to get 241. GHJ. GHJ. It's the whole circle except 90, so that'd be 270. You could say 90 plus 29 plus 151, or you could have just said 90 from 360 would have been 270. And then GJH, GJ, and H, same thing. It's all but this 90, so it's 270. Okay, HGJ, semicircle, 180. GH is 90. We have that on our picture. GHI, 90 plus 29, that would be 119. HJI, from H to J to I, all but the 29. So 360 minus 29 is 331. JHI is 209, and JIG is 270. So, once you get those main arcs in there, then you're just adding or subtracting to get the other arcs that you need. Okay. All right. The next one says circumference of a circle. Circumference can be two. You can write the formula two ways. Circumference is diameter times pi, or 2 pi r. These tell us to leave it in terms of pi, so that makes it really easy. All I have to do, since the radius is 16, double that, 32, and 32 pi inches would be the answer. Now remember, circumference is just the distance around the outside, like the perimeter of a figure. This is the circumference, the distance around it. Okay, and this one, of course, is real easy. If that's 22, 22 pi would be the circumference, just the diameter times pi. And the next one, we just double the radius. 6.8 doubled is 13.6 pi meters. So those are really simple. Now we get to some of these word problems that get a little more complicated. Let me zoom out so we can see what kind of picture I drew for this one. It says a dartboard consists of concentric circles. Concentric circles, and I didn't do a great job drawing this, but concentric circles are circles that have the same center, but they're going to have different radii. They get bigger. It's like a target. It said the radius of the smallest circle is 1 inch. Now I put 1 right here for that one. It's hard to tell, but that says 1. The radius of the second circle is 3 inches longer. So 3 inches longer than 1 would be 4 inches. Okay. The radius of the third circle is 1 inch longer than that, so it's going to be 5 inches. Now this is not drawn to scale, of course. The radius of the fourth circle is 2 inches longer than the previous, so it's going to be 7. So that's my fourth one. 1, 2, 3, 4. So it's 7. And then it says the radius of the largest circle is 0.7. Largest is about 0.75 inches larger than the previous circle. So 7.75 would be the largest radius that we're given in these concentric circles. It says, what is the difference between the circumference of the largest? The circumference of the largest, if its radius is 7.75, then the diameter would be 15.5, so 15.5 pi. And the smallest was just 1 inch for a radius, so 2 inches would be 2 pi. So the difference between 15.5 pi and 2 pi would be 13.5 pi, or 42.4 inches. So that's how I did that one, 42.4 inches. So I got this largest circle, the smallest circle, and so basically reading through this has helped you figure out what the radius of each of the circles is going to be. The next one, it says the wheel on Reggie's bike each have a 20-inch diameter. His sister's mountain bike has a 26-inch diameter to the nearest inch. How much farther does Reggie's sister bike travel in one revolution than Reggie's? So for her bike, her diameter would be, or circumference, since the diameter is 26, her circumference would be 26 pi. His would be 20 pi, and that's inches. So she travels 6 pi, the difference of 6 pi inches, or 18.8, which 19 inches, it said, to the nearest inch. So about 19 inches is how much further hers travels with one revolution. Then we have a Ferris wheel says the Ferris wheel has a 50-meter radius. Okay, 50-meter radius. So that means its diameter will be 100 meters. Okay, how many kilometers will the passengers travel during a ride if the wheel makes 10 revolutions? So the circumference of the Ferris wheel is 100 pi. Remember, because if its radius is 50, the diameter would be 100, so 100 pi meters. 10 revolutions would mean that's 1,000 pi meters. 1,000 pi meters is 3,141.6 meters. And then, of course, we convert those meters to kilometers by moving our decimal 3 places, and we get 3.1 kilometers. 3.1 kilometers. Okay, so that's how I solved that one. And number 22, this last problem, it says the marching band has ordered a banner with its logo. The logo is a circle with a 45-degree central angle. So I drew a little circle with a 45-degree central angle. The diameter of the circle is 3 feet. 3 feet's the diameter. What is the length of the major arc to the nearest tenth? Now the major arc means all of this, not the minor arc here, but the major arc here. So if that is 45, then all this would be 315. So the length would be 315 over 360, because it's a portion, it's a fractional part. It's actually 7/8. 45 is 1/8 of 360, or 1/8 of the whole circle. because there's 8 45-degree angles in 360. So the major arc would be 7/8, and then it said that the diameter is 3 feet, so that's 3 pi for the whole circumference. And then we take 7/8 of 3 pi, and then we said it was, you take 3 pi times 7/8 is 8.2 feet. Okay, so that's the math. Over on the back, on the second page, on this one it says find the length of the darkened arcs, and hopefully you can tell which one's the darkened arcs. So the length of an arc, remember, it's a portion of the circumference. Well, what portion? Well, 120 over 360. 120 over 360 tells me how much of the whole circle this piece is, because 360 is the whole circle. So 120, that wedge of it, of course, is 1/3 of the whole circle. And it's the circumference, so the circumference of this circle, since its radius is 9, is 18 pi. So 1/3 of 18 pi would be 6 pi inches. Okay, this one, the darkened arc here, since that arc is 30, this arc must be 150 because there's a diameter. So 150 over 360 times 18 pi, and I've got 7.5 pi feet. 7.5 pi feet when I multiply that out. The next one, 315. See, a minute ago we had 45 degrees here, so that's 315 degrees around there. So it's 7/8. 315 over 360 is 7/8 of 20 doubled is 40 pi. 7/8 of 40 pi is 35 pi meters. This one, the darkened arc, is all of this. Since this is 90, all this would be 270. 270. So 270 over 360 is 3/4 of the whole circle, and its diameter is 24. So 3/4 of 24 is 18 pi inches. And this one is half of the circle, right? 180 over 360 is 1/2, and the circumference would be 16.4 pi. So half of 16.4 is 18.2 pi. It said leave it in terms of pi, so that makes it a whole lot easier. Of course, we can just punch our pi button on the calculator. That's not hard either. And on this one, here's the darkened arc right here, this piece here. And they're trying to make sure that you recognize some things here. If this is 60, this angle is 60. Because of vertical angles, this angle is 60. And then, of course, this would be 60. This arc would be 60. So 60 over 360, that's its portion, 1/6 of the whole circle with a radius of 15. So the diameter would be, the circumference, the diameter is 30, so the circumference is 30 pi, 1/6 of 30 pi is 5 pi feet. Those are in feet, don't forget your units. The next one's on this picture again. I put all my measures, I put all the measures on the picture before I started answering any questions. Like, they gave me just that this is 40, that's all. They told me this is 40. Well, see, I have two diameters, which makes that kind of easy. If that's 40, this angle's 40, that would be 140, so that arc has to be 140, because this had to be a semicircle, 180, right, because that's the diameter. Well, same thing here. If that's 40 because they're vertical, that would be 40, see, because, and then that's 180, remember, because that's the diameter. And then we have one more diameter here, right here, see? And since that's 40, then this has to be 140, and then these two are congruent, so you have to divide 140 by 2, 70, 70, and these arcs would be 70. That's how I figured all those out, just, by what I know about vertical angles. I always look at diameters. Diameters split a circle into two, semicircles, which we know the measure of that arc would be 180, so that makes it a lot easier. And then we just answer the questions. What's the angle? What's the arc? The measure of angle EYD. EYD was 40. We got that one. See, I've already put the measures on there, so it's easy to identify these now. That's why it's so much easier if you can draw the picture or print these worksheets and write the measures in. Then we have the measure of EAB. It's an arc. So EAB, that's 180. That's a semicircle, remember? DB from here to here, we've got that one's 140, 70 plus 70. DYC, that's angle, DYC. So DYC, that was 70 degrees. So you got to pay attention to what they're asking. Some are angles, some are arcs. Then arc EAC is 250. AEC, I'm sorry, AEC. So that's 180, and then plus 70. So that would be 250. And then the last one they said was BDA, from B to D to A. All the circle except 40. So 360 minus 40 is 320. Okay. All right, the next one, we got some word problems. Kylie's inline skate wheels have a 43 millimeter diameter. That's be 43 pi would be the circumference, right? How many meters will Kylie travel after 5,000 revolutions of her wheels? So 43 pi is the circumference times 5,000. That would be 215,000 pi. Okay, so I went ahead and multiplied pi times 215,000 and got 675,442.4, but that's millimeters. So to move it to meters, we move the decimal 3 places, and I get 675.4 meters. So that's a fairly easy problem. Now the next one, at 5 o'clock. At 5 o'clock, what is the measure of the minor arc formed by the hands of an analog clock? Well, an analog clock has 12 different divisions. Every 5 minutes would be 12. So that means every 5 minutes is how many degrees? 360 divided by 12 would be 30. At 5 o'clock, there's 1, 2, 3, 4, 5 30s, so it'd be 150 degrees. 150 degrees. You can draw a picture of a clock to see that. I didn't draw a picture here. I just tried to explain what was going on. Number 37, my work is over here. I just did it kind of close over there. It says in circle B, I didn't even draw a circle B, but in circle B, we have a minor arc ST, and it is 3 pi inches. That's its length. And its measure is 120. Okay, what is the radius? So if I'm trying to find the length of an arc, the length of an arc would go here. It's equal to the measure of the arc over 360 times the radius times pi. I messed that up. It's 2 times the radius times pi, isn't it? Because the length of the arc is this fractional part, 120 over 360 of the diameter. And so it says the length of the arc is this, and they want to know the radius. So that would be the diameter times pi. So if that's the diameter, that's 1/3 of the diameter times pi. That's equal to 3 pi. If I multiply by 3, I get 9. Divide by pi, I get 9, but that's not the radius, that's the diameter. So the radius would be half of that. The radius would be 4.5 inches. And I'm sorry, that's not very neat the way I did it, but really I was solving for the diameter first, and then I took half of it to get the radius. Okay, these next ones are just algebra problems. Again, you have to notice that we have a diameter here. See, look on this first one. Since that's a diameter, these have to add up to be 180 because it's a semicircle, right? Or those are a linear pair. So those two add together equal 180, so A is equal to 52 in that one. Find the measure of the variable. In this one, look, we have an angle for, or we have a measure for every angle. This one, this one, this one. They all have to add up to be 360. So I added all the A's, 20 and 10 and 2, so it's 32 A's. Negative 30 and positive 6 would be negative 24 equals 360. The whole thing is 360. Adding 24 and dividing by 32, I got A was equal to 12. It's a simple equation. Same thing on the next one. Really, I know that all three of these add up to be 360. This is 90, and then we have these two. So 5x and 5x is 10x. Negative 10 and 90 would be 80. Subtract 80, divide by 10, and I got 28 for the value of x. And then number 41, down here at the bottom, this one was kind of a strange question. It says, a 45-degree arc of circle D has the same length as a 30-degree arc, angle E. What is the ratio of the radius of angle D to the radius of angle E? Well, if the arcs have if the arcs have a certain degree, see 45 over 360 is 1/8, then the diameters and the radius are going to have the same ratio. So 45 over 360 is to 30 over 360. That's 1/8 to 1/12. So it'd be an 8 to 12 or a 2 to 3 ratio. 2 to 3 ratio of the diameter, so it'd be a 2 to 3 ratio of the of the radii as well. Okay, I hope you understood those explanations. And like I said, if you didn't follow it, just go back and watch the portion you need to see again.